In the previous lecture, we have discussed the particles of matter possesses intermolecular space between them. Now today, the third characteristics of matter, that is particles of matter attract each other. Particles of matter attract each other. To know that particles of matter attract each other, we will perform an experiment. We have to take an iron nail, a piece of chalk and an ice cube. Try to bake iron nail, ice cube and a piece of chalk, iron nail, the three substances. What we have to do here, we have to break each one of them one by one by hammering or cutting. We observe that it is most difficult to break the iron nail. This one is iron nail. Most difficult to break the iron nail, followed by ice cube and then chalk piece. Ice cube and this one is chalk piece. Clear? This is because the particle of iron nail are held together by the strongest force followed by the ice cube, while particles of chalk piece are held together by weakest forces of attraction. From this experiment, we conclude that particles of matter attract each other. The strength of this force, however, differs from one kind of matter to other. Means the maximum force is in iron nail, the least force is in the chalk piece. Any confusion? Now the fourth characteristics of matter, this is particles of matter are continuously moving. Particles of matter are continuously moving. The continuous motion of the particles of matter can be explained more clearly by the experiment performed by the scientist Robert Brown. Robert Brown, name of scientist Robert Brown. Robert Brown performed an experiment. In his experiment, he took a watch glass. It looks like this. In this watch glass, he placed some drops of water, about 10 to 15 ml of water on it. Then he placed a pollen grain on the surface of water. Pollen grain, a small piece of grain, known as pollen grain. Then he placed a pollen grain on the surface of water. He placed this watch glass under the objective piece of microscope. You know, microscope, there are two lenses. One is objective lens and another is eyepiece. He observed that pollen grain is moving randomly. He observed this pollen grain is moving randomly, like this, in any direction, like this. This is the movement, random motion. This random motion or zigzag motion, this random motion, or we can say zigzag motion, is also known as Brownian motion. In the honor of the scientist Robert Brown. Brownian motion. This is. After this, we move to the next topic, that is states of matter. Very simple one, you all have studied in the previous classes. States of matter, you know very well. There are three states of matter. First one, solid state. Matter in solid state has a definite shape and definite volume. We can draw a figure for that one, that the particles of solid state are tightly packed like this. Similarly, in the case of liquid state, matter in the liquid state has definite volume but not definite shape. Definite volume but not definite shape. It takes the shape of the vessel in which it is placed or poured, we can say. This is the case of liquid. Now the third is the gaseous state. Gaseous state. Matter in the gaseous state has neither a definite shape nor a definite volume. This one we can draw a figure moving this way, 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 like this anywhere. This is gas. This we can study the characteristics of state of matter. Characteristics of state of matter in tabular form. First of all, we will write here the serial number, then the property, then the three states of matter, that is solid, liquid, and then gas. Serial number 1, we will study the shape. In case of solid, it is fixed. Shape is fixed due to its tight composition. Now in the case of liquid, it is not fixed, as we have already studied that it takes the shape of the container in which it is kept. Now in the case of gas, again it is not fixed. Even a single molecule of a gas can occupy whole volume. A single volume can occupy the whole volume due to its fast and random motion. The second characteristic is volume. Volume, again, in the case of solid, fixed. In the case of liquid, again it is fixed. And in the case of gases, volume is not fixed. Why it is not fixed? Because in the case of volume, we have already said that even a single molecule can occupy the whole volume. So it is not fixed in the case of gases. Third characteristic is intermolecular space. Intermolecular space. Intermolecular space in the case of solid, very little, very less, we can write here. In the case of liquid, little bit more than solids, you can see here, little bit more than solids. In the case of gas, it is very large. The fourth point is intermolecular force of attraction. Intermolecular force of attraction. Intermolecular force of attraction means the force with which the particles of matter are attached with each other. In the case of solid, it is very high, very high. But in the case of liquid, moderate, less than solid, we can say. It is moderate, less than solid. Third case, gaseous intermolecular space is very low. Intermolecular force of attraction is very low here. Now the fifth point, compressibility. Compressibility means we are applying force on that and the particles of matter are being compressed, or it is being taking lesser volume. Therefore, compressibility in the case of solid is negligible. Why it is so? Because very less intermolecular space. Now in the case of liquid, it is again very low, slightly compressible, we can say, slightly compressible. Now in the case of gas, it is very high. Why it is very high? Because there is very high intermolecular space. Sixth one, density. Density, very simple one. Density means mass per unit volume. Mass per unit volume in the case of solid is very high. Certain volume, number of particles are more, mass is high. In the case of liquid, it is again moderate, and in the case of gas, very low. Density is very low, you can see here. Seventh characteristics, diffusion. Diffusion, mixing with each other. Diffusion, almost negligible in the case of solids. Almost negligible in the case of solids. Diffuses slowly in the case of liquid. And diffuses rapidly in the case of gases. As you know that the incense stick, when you lit incense stick, you smell it everywhere in the room. In the case of liquid, you can see that an ink drop in the glass of water diffuses slowly, the whole water becomes blue or red, the color of the ink. And in the case of solid, almost negligible. Now the eighth point, that is rigidity. Rigidity, in this case, we can say that solid, due to high force of attraction, it is rigid. Solid body, rigid. It becomes fluid. Liquid becomes fluid, and the gases are also fluid because they have tendency to flow. Liquids, due to less intermolecular space or less intermolecular force of attraction, they slip over each other. Due to this slipping nature, they have tendency to flow. Same way in the case of gases also, they have tendency to flow.